In today's video, we're setting up a Kubernetes cluster on our Raspberry Pi using K3s, which is a lightweight distribution of Kubernetes for IoT devices and also edge devices. I want to document the whole process and show you also how you can expose your node to the network, be it the public or your local network. We're going to start off by installing K3s. So for this, I'm going to SSH to my Raspberry Pi. My Raspberry is running the latest version of Raspbian headless. For this, we need to install K3s in a specific way because we're going to have some issues with permissions. Basically, what we need to do is we're going to copy this install command, paste it here. And in addition, we're going to add this extra parameter here, which is going to solve our issues in the future. Oops, I have a mistake. So I'm missing something additional, which is this -s. So now K3s is installed and we can check out if we have any nodes already connected to the cluster, which would be only one. Running this command shows us that there is exactly one node and this is our Pi node. Perfect. This means that the installation worked. There is one extra thing that we need to do. It's this part here, which is enabling C groups, because by default Raspberry Pi OS has them disabled and this causes issues with the cluster. So to enable them, we need to edit the boot/firmware/cmd.txt, which is a file that has some configurations. And what we need to do basically is we need to add those two additional parameters to it. You basically need to add C group memory equal to 1 and also C group enable equal to memory, and this will help you fix the issues that you might experience. So now we have our K3s server running, and what we can do is we can already start creating deployments, services, etc. But the issue is that the K3s server is still not exposed to the internet. To expose it, Kubernetes, when it runs in a cloud environment, uses load balancers, and our Raspberry does not have this type of resource. So we need to somehow add a load balancer to the Raspberry Pi, which is done with the help of a tool called MetalLB. This is the documentation of MetalLB, and then we can go directly to installation and start the installation process. I'm gonna skip this upper part because K3s does not install kubeproxy. This is why we're gonna continue by copying install by manifest and then just paste the command. It's gonna set up our metal load balancer, and that's it. It appears to be done. Let's check out the pods, and yep, here it is. It's in MetalLB system namespace. We have one pod that's running and one more that's still being created. If we check out again, both of them are running. Perfect. This means that MetalLB is installed, and now what we need to do in addition to this is we need to configure MetalLB so that it knows which IP range should be used to expose the services to the network. I have already prepared a configuration which will work for my home network, and this is up to you to configure by your own needs. So this is my MetalLB file. You can see two resources being defined. There is an IP address pool and also the mode in which MetalLB is configured. If you read a little bit more about it, you can actually see that MetalLB has two node types. There is layer 2, which is the current configuration, and there's a single node that gets all of the traffic for a given service IP. And there's also the BGP mode, where each node establishes a BGP peering session with the network router and uses the peering session to advertise the IPs of the external cluster services. For our case, layer 2 is enough, so we're going to continue with it. Also, another important thing to mention is the IP range that's configured under the IP address pool resource. You can see that for me, this is from 0.10 to 0.20. So I'm setting up 20 IP addresses from my local network that are going to be given to the services which are exposed using a load balancer type. That's enough for me because it's just a home setup and it's not going to host any productive applications. It's just for testing purposes and it's enough to get the job done. So let's save the file and continue by applying it. And this is going to create the two resources that were defined, and we should be ready to go. To test this, I'm going to create a deployment of Nginx, which runs on port 80. And then in addition to this, I'm going to expose the deployment using a service of load balancer type so that we can access the deployment from our local network. So let's get started. Let's create the deployment. I'm just going to run kubectl create deployment. We're going to give the image Nginx to it and just click enter to create the deployment. And now this created deployment in our default namespace. So we can check it out by running kubectl get deployments, we're gonna see that we have a single deployment of Nginx, and now we're gonna expose the deployment using a service. So to expose it, we run kubectl expose deployment Nginx. Then we're gonna give a port 80 to it and say that it's a type of load balancer. Kubernetes has different service types, and load balancer actually assigns one of the IPs that we have available to the pod, and the pod then becomes accessible from the network. Now the service is created, so let's check out how it looks when we run kubectl get services. And here it is. We have two services. One is called Kubernetes, which is of type cluster IP, and then you can see that it has an internal IP but no external, while the Nginx service, which we created right now of load balancer type, has an internal and an external IP. So now if we copy this IP and try to access the pod from my laptop, basically from another IP from the internal network that's running at my home, you can see that it's gonna work. So I'm just gonna exit the SSH here. I'm gonna do curl, then the IP, and here it is. You can see Nginx being accessible via an IP. So this is how you can set up a Kubernetes cluster relatively fast using K3s on Raspberry Pi, and you can expose it to a private or a public network, which is enough as a starting point for a home lab to practice Kubernetes and to learn basic and advanced approaches when working with this technology. I want to say thanks for watching this video. I hope it helped you. If you have any questions or any suggestions, please put them in the comments below. And of course, like the video, subscribe to the channel, and ring that notification bell so that you can get my content as soon as it's uploaded. Thanks for watching, and see you in the next video.